Right, graphing a sine function in the form of a sine of omega x. So here we don't have that plus alpha or plus c value out at the end, and we don't have a vertical shift here. So the first thing I'm going to do is look at this. And I look at this. When I first started looking at this, I was a little bit put off because I saw this negative sign here, and I thought to myself, this is not going to have much impact. But it does, and the reason that it does is because of the negative formulas. The negative formulas say this. In the case of sine, says that sine of opposite theta, or negative theta, is the opposite of sine of theta. So having this is the same as putting this negative sign out here. So I'm going to put it out there if you don't mind, just to have a look at it. Now I'm just going to start after this thing, keeping in mind that we have a Cartesian plane. It's going to look like this. I'm going to just try to graph about one period of this thing, and I think it's going to look a little bit like, well, first off, here's my hint to you, is that I know it's opposite, so its sine usually goes like this, doesn't it? So it's going to go the opposite way. I'm just going to try to graph what I think is a good looking sine curve, maybe something like that. Pretend, if you don't mind, that we have symmetry here, and we also realize that this thing is going to go and do this here, and it's going to go and do this here, etc. But I'm just looking at this solid part right here, and I'm trying to figure out some stuff here. One thing I know is it has an amplitude of 5/3. Remember, amplitude is the absolute value, so it's the absolute value of 5/3, of negative 5/3, which just happens to be 5/3. And what that tells me is this. It tells me that its maximum height is going to be 5/3. So I'm just going across from here. I'm saying this is 5/3. Its minimum height is also 5/3, but it's negative 5/3. So I get that. I know this point is the point 0, 0 on the graph, isn't it? And now I'm going to work on the period because I want to figure out what this point is right here. And what we know about the period of a curve is that period of a curve, of a sinusoidal curve, is 2 pi over absolute omega. And omega in this case is 2 pi thirds, so over 2 pi thirds. So this is what I did. This really helps me. I'm not getting rid of this 2 pi. I'm just going to put it up here like this so you can see it better. And now, if you can see, we have a complex fraction. I'm just going to use the rule of complex fractions, which is that we leave the numerator the same, 2 pi over 1, times the reciprocal of the denominator, which is 3 over 2 pi. So the 2 pi's cancel out, and we have a period of 3. So this is the point 3, 0. Right? Usually we want 5 markers on a curve. So the next marker I'm going to use is this one, and it's the point, well, I'm going to this halfway mark. So I'm going to use midpoint theorem. I'm going to do 3 plus 0 divided by 2 is 1.5, or 3 halves. So 1.50 is this point right here. And then if I want to find what this point is right here, I know it has its y value is negative 5/3, right? But what's the middle point? Well, I'm going to use midpoint theorem again, and I'm going to take this 1.5 plus 0, 1.5 plus 0 divided by 2, which is equal to about, not about, it's equal to 0.75, or 3/4. So this is 0.75 here. I can do the same thing here. I know this has a maximum height. This is a maximum, and I know that height is 5/3. So it's got some point 5/3. The question is, what is the midpoint? So what I'm going to do is I'm going to find the midpoint of 3 and 1.5. So I'm using midpoint theorem again, and I'm going to do 3 plus 1.5, right? The second x value plus the first x value divided by 2. And that gives us 4.5 over 2, which is 2.25. If you want to do it that way, I don't care if you want to set it up as a fraction, but it's like that. And I think we've done a pretty decent job here. So that's how I'd work that out. Please keep in mind, because I really did mess this up earlier, is that when that negative sign is here, you can switch this because of this, that sine of negative theta is the same as the opposite sine of theta. Hope this is helpful. This is tough stuff, you guys, so stick with it. If you need help, let me know. If you haven't already subscribed, please subscribe, and your comments are always welcome. Thanks.